Calculating curve length using calculus. It looks little weird and strange and funny, but sometimes it is very difficult to find any curve length which has algebraic equation in Cartesian coordinate. So finding that curve length through calculus. So that is the concept. Can we find the curve length using calculus? Example can be I have a circle. I have a circle. Then what is parameter of a circle? How big, how long the parameter of circle? Or if I have a rectangle or if I have a square, then what is the length of the parameter boundary? If I have ellipse, then what is the length of the ellipse? I mean any any curve which has algebraic equation. Okay, idea is that through calculus, I mean how I can calculate the perimeter of a circle, not possible. Okay, I can just I know perimeter of a circle is 2 pi r if it has radius r. This proves that if I multiply radius by 2 pi, then it becomes parameter. If there is a circle, if there is a circle and there is a radius r, then if I rotate radius 2 pi angle, then it becomes the parameter 2 pi r. That's how radians came into the picture. 2 pi 2 pi where pi value is 3 point something 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 1 4 or something. 2 pi r is the parameter of circle. Parameter forms when I rotate the radius 360 degree or 2 pi. So 2 pi is a radian that it came into the picture, which is complete rotation 2 pi. Now, if I want to calculate the parameter of any angle theta, then it is r theta. If theta is 2 pi, theta is 360 degree, r theta, where theta is in radian. If theta is 2 pi, then it is 2 pi. So nice. But this does not hold that I know how to calculate the parameter of a circle. This is not the actual way of calculating the parameter that 2 pi into r. So parameter is 2 pi r. If I know parameter is 2 pi r, then I can say this is because radius rotated 360 degree. If radius rotated 360 degree, then I can say the angle is 2 pi radian. But what is the way I can calculate parameter of any curve if I have the algebraic equation? What is the algebraic equation here? If I have a center, if I have a center that is origin, and around the origin I have the circle. Center x-axis, center y-axis, and if this is two-dimensional, then x-axis is called independent component and y-axis is called dependent component. How dependent component y is drawn is y is a function over x. What is function over x is function is a Python function which has a parameter x. If it takes x as parameter, if I pass x some value, then it returns another value. This is function over x. So function over x is y. If I pass x to the function f, then it returns some value that is y. So if this is x-axis, then against each x, I have a y that is vertical. So if I have 10 x points, again each 10 x point, I have fx point, 10 fx point vertical. If I connect all the points vertical, then it will make a curve. What is the length of the curve? If I have the algebraic equation, that is a prerequisite. What is algebraic equation of a circle? That is x square by radius plus y square by radius equal to 1. I mean, this is the equation of ellipse. X square by radius along x-axis and y square radius along y-axis equal to 1. X square by a square plus y square by b square equal to 1. Now, if that is true, then here x square by r square plus y square by r square equal to 1. So, equation of circle is x square plus y square equal to r square. Let's consider that radius is 1. So, x square plus y square equal to 1. This is the equation. So, what is dependent and independent component equation? Y equal to 1 minus x square square root. That is the equation. Now, if I keep changing independent variable x, accordingly I would get the y. If x is 1 that equal to radius, then y is 0. Means if this is origin and this is x-axis, then along the x-axis, if I have a point 1 comma 0, then at this point the circle, if I draw, at this point the circle height is 0. If this is the origin and this is the radius, I draw a circle, then at this point if x is 1, then height is 0. Y equal to square root of 1 minus x square. If x is 0, then y is 1, like this. Now calculate the parameter of the circle, that is in question mark. How I can calculate? Okay, so a person is walking. Person is walking. Now he is walking in a way that he is collecting 5 kilometer per hour. This is his speed. So speed or velocity is 5 kilometer per hour. How much, how many kilometer he has walked or how many kilometer he has collected at the end of 3 hours? 5 kilometer per hour at the end of 3 hours. So if hour is independent component x-axis, then speed is y-axis fx. So 5 kilometers. So the vertical is 5. So 5 kilometer per hour is the constant. At any hour, if I check the speed, it is 5 kilometer per hour. If I have rate of change means change in kilometer per hour. Kilometer means if I start from 0, then at every hour, okay, whatever means every hour, what is the collection? What is the rate of change per hour? So means what is rate of collection of kilometer per hour? If that is, this is also called velocity. Velocity means in any term velocity, not only distance wise velocity. Velocity vector. So per hour the collection is 5 kilometer per hour. So this is a rectangle now. If this is hour is x-axis and vertical is fx, that is speed, velocity, kilometer per hour, rate of change in x, then if I get the area of this rectangle, that gives me total collection, total kilometer. So if I have a rate of change, if I have velocity vector, and if I calculate the area means if I integrate it. So if this is hour is denoted by x, then y dx integration, that is a funny notation to actually calculate the area. If I draw dx means x-axis. If I have x-axis and y-axis and y I have algebraic equation, then limit left to right I take, then I get the area. The area is net collection. This is integration. Now, if I have formula as 5 kilometer per hour means 5, y equal to 5. Y means vertical, in which direction it is changing. It is changing along the independent component x direction. So, dependent y dx integration from what to what? From 0 time to 3 hours. 0 to 3. So, 5 integration is x. So, 5x. 0 to 3 means 15 kilometer he has collected. If he has collected 15 kilometer in 3 hours, then what is the rate of change, rate of collection of kilometer per hour? So 15 kilometer net collection by the rate of change means in per hour. by 3 hours. So 5. So that is nothing but y by x. Net collection is y and net hour is 3. Y by x is gives me the velocity vector. If I have velocity, if I integrate y dx, then I get the area, that is the net collection. So y by x is dy by dx. So dy by dx, through differentiation, if I have net collection, then I get the velocity vector. If I have velocity, then if I do integration, then I get the net displacement. So this is the concept. Now we will apply this concept to calculate the perimeter of a circle, but it is not that straightforward. Okay, that's why we are here. Everything what we are talking, it is new. Each video we are going to file disclosure. It is not available anywhere else. You can check. Now I have to find perimeter of a circle. Okay. Now idea is that if I have velocity vector and if I integrate it, I get the net displacement. If I have velocity vector 5 km per hour and if I integrate it with some independent component, the net collection I can get. So if I get velocity vector for the parameter of the circle and then if I integrate, I get the complete length. A person is walking from 0 point and 5 km per hour, that is the velocity vector. If I integrate along the independent component, that is hour, then full distance I get. If I have a perimeter of a circle and that perimeter velocity vector if I get, if I integrate with the independent component means x-axis, then I get the perimeter where to get the velocity vector. Now to get the velocity vector, I have to find the position vector. Position vector is nothing but a circle. If I have a circle, it has a center. Circle has a center and then there is a circle. If the center is origin, circle is centered on origin with radius r. Now any point on the circle parameter boundary, if the x distance along the x-axis is x, then vertical distance y is 1 minus x square square root. This is what we saw. Because radius is 1, then equation of circle is x square plus y square equal to 1. Then y, that is vertical, that is function over x, is 1 minus x square square root. So at any point, if I see with any point if I see x comma y, if it is x, then y is the square root of 1 minus x square. Now, if I draw a position vector from the origin to this point, then position vector would be xi plus a square root of 1 minus x square j. What is changing? If I go from one point to other point, then algebraic point, Cartesian point is changing. I don't want. I want velocity vector. Because velocity vector has a direction, I can do calculus on that. With position changing, what I'll do calculus over it. Calculus means rate of change I can calculate by differentiation. If I have rate of change, then I can calculate the net collection change. If I have, I can. So through the integration. Now from the origin, if I take any point x comma y, if I connect it, that is called position vector. From origin, if x comma y is a point, if I draw a vector, then x minus 0, y minus 0, the vector equation is xi plus yj, where yj here is square root of 1 minus x square. So I have position vector of any point is xi plus a square root of 1 minus x square j. This is not available anywhere else. Now, if I want this position vector to be a velocity vector we want, because if I integrate the velocity vector, I'll get the length. That is the concept. So this position vector, how this position vector, now this at point x1, y1, then the position vector is x1I plus square root of 1 minus x square j. At another point, the position vector is x2I plus a square root of 1 minus x2 whole square j. Okay, so x keep changing, then position vector keep changing. Position vector keep changing. How much position vector would change if there is change in delta x on x-axis? If I have a point on x-axis, that point is x. So at x, I have position vector xi plus a square root of 1 minus x square j. If I move little bit along the x-axis like x plus delta x, then what would be the position vector? Then x plus delta xi plus plus 1 minus x plus delta x whole square. So what is the change in the position vector we see when we make a small change in along the x-axis? D position vector by dx. If position vector is r, now it is something like parameterization. It is not exactly parameterization, but still position vector is a vector which is a function over x. So I can say rx or px. P is a position vector. P, write P on top of it, place an arrow, is a vector, and in braces write x. It's a parameterized vector which is a function over x. So px equal to xi plus a square root of 1 minus x square j. What is dp by dx? Means if I change along x-axis at point x, delta x is the change, then how much the position vector would change. I'm not talking about vertical, how much vertical would change. How much this position vector would change. dp by dx. dp by dx means change in position vector when there is a small change in x. dp by dx. dp by dx now is I minus x by square root of 1 minus x square j. Differentiation of a square root of 1 minus x square, that is 1 minus x square to the power 1 by 2. That is 1 by 2, and then 1 minus x square to the power minus 1 by 2. Again, x square, 1 minus x square differentiation is minus 2x. Chain rule. So it will become minus x by square root of 1 minus x square. So now dp, this information is, again, it is not available anywhere. So dp by dx is I minus x by square root of 1 minus x square j. This is the velocity vector. Okay. Now, if I integrate it, I'll get back the position vector. This is what we don't want. We want the length. So, if we want the length, then we want the magnitude, the power of position vector. So, what is the magnitude of velocity vector? I plus xi minus x by square root of 1 minus x square j. Now, the power of this velocity vector is x square plus y square square. This is the power of velocity vector. Okay. Now, it will become 1 square plus then x square by square root of 1 minus x square, and then net square. This is how it is. So I minus x by square root of 1 minus x square j, the magnitude is x component square, y component square, square root. So 1 square plus minus x by minus 1 minus x square root square, that will become x square by 1 minus x square. 1 plus x square, 1 minus x square. If I take it to numerator, then 1 minus x square plus x square divided by 1 minus x square. So that will become 1 by 1 minus x square root. So it will become 1 by square root of 1 minus x square. This is the amplitude, this is the power of the velocity vector. Now, 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 since the velocity vector so what is velocity vector? If I have a circle, if I have a circle centered on the origin, then if each point is position vector, then at any point, if I calculate dp by dx, then it is nothing but it's like the tangent over the position vector. So if this is the position vector that is radial, then dp by dx is will be perpendicular to the radial vector, that is position vector. So it would be like tangent. So velocity vector is nothing but tangent at any point on the circle, the point at which I am calculating the differentiation. Now the velocity magnitude is now it is 1 by square root of 1 minus x square. Now since we are calculating the variation along x-axis dp by dx, now if I do dp by dx integration, I'll get the p as the length because we have taken the magnitude. So dp by dx and then integration from minus 1 to plus 1. This is the limit of the x, minus 1 to plus 1. So 1 by square root of 1 minus x square dx and then limit minus 1 to 1. This will open a big arena in calculating the curve length, then area of any surface, volume of any 3D and so on. Very powerful. So now we know that it is 1 by square root of 1 minus x square dx and then integration minus 1 to plus 1. This is how the circle is centered at the origin and limit is minus 1 to 1. Now what is integration of 1 minus x square? Consider x equal to sine theta. X equal to sine theta. Then dx equal to cos theta d theta. Then dx I replace with cos theta d theta. Cos theta d theta. Divided by 1 minus sine square theta comes to as cos square theta. Cos square theta square root is cos theta. Cos theta by cos theta gone. Only d theta. So d theta integration from minus 1 to 1. So that will come as 2 theta. Okay. So it would come as 2 theta. Okay. Now or anyway, let's proceed. Or I'll see. So it will come as theta d integration of theta. So it will become theta. Leave the minus 1 to 1. It will become theta. What is theta? Because limit is from x in term of x, not in term of theta. So integration is theta now. Integration of 1 d theta is theta. Sine theta equal to x, then theta is equal to sine inverse x. Now I can place the limit. Sine inverse x is the integration minus 1 to 1. What is sine inverse of 1? Sine pi by 2 is 1. So pi by 2 plus pi by 2. So the half of the parameter minus 1 to 1, if I have taken half of the parameter, the length is pi. The length of the circle is 2 pi. Okay. So through Cartesian coordinate also we can calculate the curve length. Now if this is the methodology, then the opportunity is infinite. Now suppose that I want to calculate the perimeter of a rectangle. Now rectangle, one side is minus 2 and other side is 2. The width of the rectangle or a square, one side is -2, other side is 2, and it is centered on the origin. Now this is a square and centered at the origin. Now let's calculate the length of one side, then I can multiply by 4. So one side if I take, then the height is 2, means its length is 4 centered at the origin. So if from origin height is 2, what is the position vector at any point? So that position vector is xi plus yj. Y is constant 2. So xi plus 2j, xi plus 2j, dp by dx is I. J component gone. Only I. Now dp by dx integration from -2 to 2. So if it is I, then first I have to calculate the magnitude. So magnitude is 1. So 1 dx, then it is x. X from -2 to 2, it will come as 4. So length of the one side is 4. So the if it is a kind of from origin, if it is 2 to the length is 4. It's simple, right? Now we can try for the ellipse also. Okay, I believe it is kind of homework. Someone can try x square by a square plus y square by b square equal to 1. That is the ellipse equation. So someone can try, and you can kind of calculate x square by a square plus y square by b square equal to 1. If this is the equation of any ellipse, then what would be the parameter of the ellipse? Okay. Now let's try in the kind of radial component, radial coordinate system, polar coordinate system rather, polar coordinate system. Polar coordinate system where the parameterization of a vector is done in terms of angle. Now, if I have a circle and that is centered at origin, and there is a radius r, and r moves theta degree and it rotates complete 2 pi, then it becomes a circle. Then at any point if I calculate the vector p, then it is cos theta I, r cos theta I plus r sin theta j. That is the x and y component of the position vector, r cos theta I. So if theta is 0, then cos theta is 1. So ri plus 0j. So only x component is there. If theta is 90, then cos 90 is 0. So it will only be sin pi by 2 j, means r sin pi by 2 j means only r. So r cos theta I plus r sin theta j. Now radius is 1. Someone can try that circle we have given as ellipse x square by a square for any radius not equal to 1 also, for just for circle, any radius a. Now here again radius is 1. So cos theta I plus sin theta j. What is velocity vector now? Cos square theta plus velocity vector I have to differentiate. So it becomes minus sin theta I plus cos theta j. Now what would be the amplitude of this vector? That is cos square theta plus sin square theta square root. That is 1. Now if I have to integrate it, okay, then theta is the independent component. Theta is varying. Cos theta I plus sin theta keeps varying. So theta is the independent component. So 1 d theta, where theta varies from 0 to pi. So that will become theta, and then 0 to pi, that is pi, twice, then 2 pi, or 0 to 2 pi, then 2 pi. So through the polar coordinate and through the Cartesian coordinate, this concept works very nice. But polar coordinate example you will find in the book, but Cartesian coordinate example with this kind of explanation, that we go for dp by dx, y, and why it is varying in x component, this is badly missing. People go for an explanation of this concept that is away from many of the mind. Come with some Vx, Rx, and then delta x is the area and means length, and then you map to a parallelogram, then there will be tangent and so many. Okay, so people try to come as a approximation. This is what people consider integration. Integration is calculation of area through which we get the addition. This is the integration. But people think that integration is nothing but it's a very minute way of calculating one particular area, and add all the area, you will get the integration. This is completely false. That's why we are here. Otherwise, books are there for the calculus. Calculus that is being taught in the book are wrong. Whatever the book you see on the calculus, all the global and local books, all are wrong. Calculus is never approximate. Mathematics is never an approximation. This is a false belief in people that mathematics is approximation. If I have a curve equation, then I chop it into infinite, very infinitesimal small width chopped kind of section, where each section tends to become a rectangle. Then I calculate the rectangular area of every chopped section. Then if I add, then I can calculate the net integration. This is false. This is true, but that is approximation. Approximation is used where you don't have any other way. Okay, it is kind of compulsion. Okay, but this is not the calculus. Calculus is pure based upon the algebra, where you have to calculate the area. Straightforward. Okay, you have, if you don't know what is the area of a particular algebraic equation, then break the algebraic equation in a form that you know the area. If you still don't know, keep breaking till you come to a level where you know the area. Then go up and calculate the area. So the people think that delta x, if I take, then infinitesimal small one rectangle will come, and then this vector, that will, all are false. So calculus is person who does mastery in algebra. It's a pure algebraic science, and it's not approximation, because if you start using calculus in life saving area or space sciences, then those places where you start doing approximation will take away many one's life. With the approximation, if something changes in point also, in decimal region also, then you will take away many one's life, because the machine, the electronic machine who is doing the computation with minute changes, then he can do, or in defense section or something like that, then your torpedo or your missile should go in this direction. If it takes the angle that is in nanoradian, 10 to the power minus 9, different, then think that if it is firing 3000 kilometer or 4000 kilometer, how much distance, if digression is only for 10 meter also, then it missing the target. Okay, 10-meter digression, if it is nanoradian difference it is making with the approximation in the calculus, with 10-meter digression from the target, you are losing the war. Okay, so not even a penny, 10 to the power minus infinite, that much error is acceptable. Not even a penny, nothing, no error is acceptable. That is calculus. So calculus must happen through algebra, not through approximation. Approximation is nice, it should be used, but not the explanation. Approximation can be used where there is no other way. Then approximation is very. Now we have a way, y equal to a square root of 1 minus x square, and then I am able to do differentiation and integration correctly, then it is all right. Otherwise, we can go for, it is also called kind of numerical integration, where we divide. If I'm not able to get the integration, then I can subdivide the algebraic equation into many regions, and then mean value I can take and then calculate with the width, means every one rectangle area you calculate, then do the approximation. But certainly it's a good idea if someone has invented, I believe. Sir Newton. So he invented the calculus. Then if not everything for if integration like integration by part or chain rule that happens in differentiation, if these are the way available for the differentiation integration proved way, and some way is not available, I am not able to find the integration of the a particular function, then you have to invent it. After all, nothing is given by the God. So move ahead and do some kind of invention. So that is required. And then you can, anyway. So this is the way that we can calculate the curve length. We will move on and then we will have more example. Then we will see calculation of area of a surface, volume of a cube, or volume of a kind of three dimensional entity. So those things we will see. We will really have fun in calculating the area, or it's a kind of come under section called line integral or flux integral. So later we'll see line integral, flux integral, curl integral, and those are based upon it mind blowing, interesting. So that we will see.